Hi, so far we have been talking about internal sorting algorithms. Okay, so all these sorting algorithms, insertion, quick, and merge, heap, radius, all these are internal sorting algorithms. Internal sorting algorithm means they are done in the main memory. But sometimes, recently we have a big data, right? So big data has been a big word for a long time already, and especially in recently in AI, artificial intelligence. The intelligence of machine is hugely based on the data. So to improve the performance of the accuracy or the level of performance, we need more data. Okay, so basically we need big data. So when the data size is huge, then we cannot actually load all the keys into the main memory. So when it's not possible to load all the keys into the main memory, then what should we do? We cannot keep all the data in an array. Then what should we do? So external sorting is all about that kind of issue. Okay, so when the data size is too big and compared to the memory size, then we have to sort the file in the disk in a sense. Okay, so external sorting is about that. Okay, so external sorting is sorting files which is too large to store in the main memory. Okay, and the file is stored in the disk or magnetic tape. So magnetic tape is long time ago, so we don't care the magnetic type that much, but still we use magnetic disk, right? And recently, we can use SSD, solid state disk, and the solid SSD is quite faster than magnetic disk, hard disk. Okay, but still, we might have some big data in the magnetic disk too. But anyway, it cannot be in the main memory. It's too large. Okay, then let's talk about this latency in the disk access. So when we have a hard disk, okay, magnetic disk, then we have a seek time and latency time and transmission time. Seek time is the time to find the right track. So in your hard disk, actually we have lots of this, and then we have multi-heads like this, and seek time is to find the right track. So in this disk, we have lots of tracks like this. Okay, then first one is to find the right track. Okay, then we have to move this head going forth and backward, then forward. Okay, so it takes some time. It's kind of mechanical movement. And next one, we have to find the sector. So we have to rotate this disk to find the sector. So in one track, we have lots of sectors. Okay, so we have to rotate this disk to find the right sector. So now this one is right sector right below this header. Okay, and then now we found the sector, then we have to transmit the data. So there is a time to transmit the data from disk. Okay, so it takes a lot of time, but still, when our memory space is not that huge or our data is too large, then we have to have magnetic disk to store all the data, and then we have to handle this kind of latency anyway. But if you have SSD, then it will be much faster, but still. Okay, so now let's talk about external sorting algorithms. Basically, we're going to use internal sorting in the middle of these external sorting algorithms. Most popular method for external sorting is merge sort. Okay, so merge sort is actually an internal sorting algorithm. So we could merge all the lists in the main memory, but we can use it on the file disks. So we have a huge data, and then first split the file into multiple files. Okay, so we have 1 terabyte file, and it's too huge, and we split it into, let's say, millions of megabytes. Then we can sort all these small files in the main memory. Okay, So let's say we have 1 million files. Then we can read one file at a time into main memory one by one, and then we can sort that using any internal sorter like a quick sort. Let's say we can use quick sort. Okay, now all the files are sorted. So 1 million files are sorted within the file. Good. And then we can use a merge sort. Okay, so first read two files, and these two files are sorted within the files. Okay, then we can merge. How? Instead of moving the index in the merge sort, we can use a file pointer. Okay, and we can read first lines from two files, and then we can compare the keys. And if the left file's key is smaller than the right file's key, then print out this line into merged file. Okay, and then read the next line of the first file. Okay, so let me draw this. Let's say we have two files. Okay, and as I said, this file is already sorted, and this one is already sorted too. So when we sort, we can use a quick sort for this file and quick sort for this file. Okay, now we have two sorted files, and read the first lines. Okay, and we can compare the keys. If this key is smaller than this key, then in the bigger file, write this line, and then read the next line, and we can compare this line and this line. And if this line is smaller than this one, when we compare the keys, then this line is smaller than this one, then we write this line here, and then read the next line. And now this line is smaller than this one, then write down this line into the merged file. And in this way, we can actually use that same algorithm, right? So we can use the merge sort algorithm in this way, but in this case, we use files. Instead of indexes, we read the file lines. Then we have a bigger file. Okay, so in the merge sort, in this case, we don't use memory space that much. We actually load two lines into the main memory, and then we compare and we write down one of them into the file, the merged file, and then we read another line. So all the time we have just two lines in the main memory. So we don't use much of main memory space. Okay, so after merging two files, then what else? We can merge another file. Okay, so if we have another file, then we can merge this one and this one to make a bigger merged file. So in that way, we can have a sorted file. Okay, so basically we will generate lots of temporary files. Okay, so this slide shows how we can sort a big file. So basically we have a huge file like this. In this, we have all the characters A, B, C, D, E, F, G, H, etc. And then we split this file into the many files, and then merge and merge and merge, as I said in the previous slide. Okay, and then merge and merge. Now we have big merged file. Okay. And this slide summarizes the time complexity of sorting algorithms. Okay, so if you look at these ones, we have quick sort, merge sort, heap sort, insertion, and selection, and the radix. Okay, and we have a best case, and average case, and worst case. But the best case for quick sort is different from the best case for the merge sort. Okay, so usually already sorted list is the best case for most of sorting algorithms, but that's the worst case for quick sort. Okay, if it is sorted, then you should not use quick sort. Okay, that's it. So now we are done with the sorting algorithms. Okay, then if you have any questions or comments, then here's my email address. Okay, thank you.